Go. Late Pizza Friday! For today's experiment on density, we're going to use some household products that you can find in your own house. It's simple and easy to do this experiment, so we try to make it as quick and easy as possible so that you guys can replicate or try it at home. Some of the things to do this activity with are included on the table so that you can see just what you can do. First of all, as a scientist, please use safety. So we have some safety goggles. Well, you don't have to have safety goggles, but please make sure you don't do anything near your face or stand over anything you are working by in case something splashes in your eye. We also have the basic supply list of things that you need in order to make these lava lamps. To make them, you need half and half part oil. It can be vegetable oil from your grocery store. Half water, either water out of a bottle or water out of the sink at home. You need some type of measuring device. We have here in our demonstration 2 graduated cylinders that we use, but you can also use a simple measuring cup like you find in kitchens at home. We also have paper towels, which are handy dandy for cleaning up your mess. Food coloring, so that we can make the different colors or choose your favorite color to make for your homemade lava lamp. And of course, our agent that helps in creating the action that you will see in our lava lamps in just a few minutes. So to get into this, we'll give you a demonstration of how exactly density plays a part in these homemade lava lamps.
Okay, to start off with, we took 200 milliliters of water just out the faucet and put it into a bottle. Then we measured out 200 milliliters of vegetable oil. So we have 100 milliliter graduated cylinders, so we each have one to pour in. So I'll go ahead and pour mine in. And like Ms. Guidry mentioned before, it's equal parts water and equal parts vegetable oil. And if you look at either side, we have 2 already set up. You can see how they settle. Okay. And then next, we pick your favorite color for of food coloring. So go ahead and let's pick our favorite colors.
I'll choose blue.
Okay, Ms. Guidry is going to have blue. And you're going to put about 8 drops of food coloring. Make sure you notice what happens as the drops go in.
Oh, I think I put 9. That's why I don't teach math, guys. Don't know how to count.
Okay, and you can kind of see what's going on within the 3 bottles.
All right, and now we are each going to put half a tablet of our Alka-Seltzer into our bottles and watch and see what happens.
And guys, the only reason we're putting only half of it is because we kind of experimented before to see what would happen, and the others were a whole tablet was a little too much. It was over, and we wanted you guys to see what was happening. And there is the magic of a lava lamp, except there goes my blue.
Yeah. Yay.
My blue stayed. There it's going.
Okay, and Ms. Guidry, can you tell them what's going on with that? The scientific.
All right, guys. So just looking at these homemade lava lamps, we can see that density is definitely plays a factor in the ability of. Thank you. Watch your hand. All right. Density is definitely playing a big part in what's going on with our lava lamps. Basically, to figure out how the density of something works, we have to know the mass and volume of each item and be able to take the mass and divide by the volume. If we have equal parts of oil and water, which Ms. Polides demonstrated by adding equal parts to each one and measuring everything out in the cylinder, we can see prior to that most of the water dropped to the bottom and the oil stayed floating or somewhat floating towards the top. That reaction is a normal reaction because the molecules of water molecules are tightly packed together and are able to sink further down because they are denser. However, the oil is less dense, the molecules are spread out, and they tend to stay floating. Now, you would kind of think kind of similar to some of the things you've heard about and seen about before, that oil and water don't mix, and that is the theory behind this, but that is not the only theory. It is one of these facts. The density plays a part, but there's also a new science word called polarity. Polarity is the ability of the water molecules and the oil molecules to separate because their polarization is opposite of each other. Water molecules are polar molecules, where their electrical charges attract the atoms. In the oil, it is the opposite. They are nonpolar. They do not have positive or negative charges, and they do not attract like the water molecules. Therefore, polarity pulls them apart. They will not mix. Normally, items will eventually mix together to make a complete mixture. Oil and water will not because of polarity. Guys, if you want to do something like this at home, you can make your own homemade lava lamp using the same products we have here. You can experiment with density with vegetable oil and water, and you can also use the Alka-Seltzer. Alka-Seltzer is used in this homemade demonstration because the bubbles that are created are done so because the bubbles from the Alka-Seltzer attach to the water molecules and make them lighter and make those water molecules actually rise to the top. So as it does that, it shows that bubbling action, which mimics an actual lava lamp. A real lava lamp, if any of you have those lovely things, or if you've seen one before, you know that it uses heat from a light that creates the bubbling action, and the heat from the light is what causes it instead of the Alka-Seltzer with the bubbles. So those are a little trickier to make. They're not as safe to try and experiment with at home, but the products we showed you today are very safe and easy to handle. So no hazards here. If you want to try this lovely trick at home and experiment with density, go ahead, be a scientist. Thanks for being here at Leaping Into Friday Density Experiment.